Hello everyone, welcome to Infinity Learn by Sri Chaitanya. Let's start today's paper discussion, that is LTC AIIMS physics paper weekend test 13. So let's start with the question number 1. What is the Coulomb's force between two alpha particles separated by a distance of 3.2 into 10 power minus 15 meter? So we have two alpha particles over here. Charge on one alpha particle is equals to 2e. So this will be 2e charge and this will be 2e charge, where e is 1.6 into 10 power minus 19 coulomb, right? And the separation is given as 3.2 into 10 power minus 15 meter. So force of attraction or repulsion between two charged particles is given by 1 upon 4 pi epsilon naught q1 q2 upon r square. 1 upon 4 pi epsilon naught is what? 9 into 10 power 9. q1 is 2 into 1.6 into 10 power minus 19. q2 is again 2 into 1.6 into 10 power minus 19 divided by r square will be 3.2 into 10 power minus 15 whole square. So after solving this value, you will get the force between these two alpha particles as 19 Newton, which is option 1. Question number 2. We have 2 point charges plus 3 microcoulomb and plus 8 microcoulomb, and they repel each other with a force of 40 Newton. So let's say separation is R. So in this situation, force 40 Newton is what? K q1 q2 upon r square, which is 3 into 8 into micro square, that is 10 power minus 12 divided by r square. In the second case, what we are doing is we are giving a charge of minus 5 microcoulomb to each of them. So first charge will be minus 5 plus 3 minus 2 microcoulomb, and second charge will be 8 minus 3, that is 3 microcoulomb. So one is positive and other one is negative now. So force of attraction will be there. So force of attraction is, let's say, F, and that is equals to K into minus 2 into 3 into 10 power minus 12 divided by r square. This is equation 1. This is equation 2. Let's divide equation 2 by equation 1. We will get F upon 40 is equals to minus K into 6 into 10 power minus 12 divided by r square divided by K into 24 into 10 power minus 12 divided by r square. When you cancel this with this, you'll get your force Fs over here minus 10 Newton. Minus sign shows that the nature of the force is now changed. It is earlier repulsion, but it is attraction in the second case. So correct answer will be option 1. Question number 3. We have a hollow metal sphere of radius r, capital R, and it is uniformly charged. Okay. The electric field due to this sphere, at a distance r from the center is. So this is a hollow metallic sphere. That means electric field inside will be 0. There's no charge inside, and electric field outside varies as a electric field of a point charge. So electric field outside the sphere, when r is greater than equal to r, it will be kq upon r square. Okay, so you can see that it is 0 up to r is equals to r. When the value of small r reaches the surface, after that electric fields become non-zero, and it is inversely proportional to r square. So as r increases after the surface, the value of E decreases. So correct answer will be option 3, 0 as r increases from r less than r, and decreases as r increases from r greater than r. Next is question number 4. A force of 16 Newton is acting between two charges in M. If the space between them is completely filled with glass of relative epsilon as 4, then the new force will be. So new force with any medium F dash is given as force in air divided by force in air or force in vacuum divided by epsilon r. Right, so it will be 16 upon 4, that is equals to 4 Newton. So correct answer is option 4. Question number 5. If an electron has an initial velocity at an angle with the electric field, then the path of the electron is. So let's say we have, this is the reference line with which the velocity of the electron, this is electron, this is velocity vector of the electron, and it is making an angle theta with the direction of electric field. So let's say this is electric field direction. Okay. Now if you look at the components of the velocity of the electron, it will be v cos theta in horizontal direction and it is v sin theta in vertical direction. Right. Since this is electron, that means it is a negatively charged particle. So force due to electric field will be in the opposite direction of the electric field. Right. So if electric field is towards right, then the force on the electron due to this electric field will be EE and that will be towards left. So acceleration due to this force of electric field will be force divided by mass, that is EE upon m. So you can see that particle has two velocities initially. It is v cos theta, v sin theta, and acceleration in only one direction. Right. So this is something similar to projectile motion, and the path of the projectile is what? Parabola. Right. So similarly we'll find same answer over here. So let's discuss what will happen. So I'm just assuming that this direction is x and this direction is y. So in x direction, initial velocity ux is v cos theta and acceleration ax is minus ee upon m. Similarly, in y direction, initial velocity uy is v sin theta and ay is 0. So let's say after some time, velocity displacement in x direction is x and displacement in y direction is y. So you can write x is equals to ut plus half at square. So it will be v cos theta into t minus half ee divided by m into t square. I'm just using this equation. X is equals to ut plus half at square for x-axis. Similarly, you can write this equation for the y-axis also. Y will be ut plus half at square. So u is v sin theta, time is time, and half at square will be 0 since ay is 0. Right. Now from second equation, you can find the value of t as y upon v sin theta. Okay, let's put this value in the first equation to get the relation between x and y, and this will be the final result. Okay, so x is equals to v cos theta into y upon v sin theta minus half ee divided by m into y upon v sin theta whole square. So you can cancel v with v. So we have x is equals to y cot theta minus half ee divided by m y square upon v square sin square theta. So this is the equation between x and y. So this is nothing but the equation of a parabola, right? So that is why path of the electron will be a parabola and option 4 is correct. Next question is question number 6. ABC is an equilateral triangle. Charges plus Q are placed at each corner. We need to find electric field intensity at O, say the centroid of the triangle, and R is the side of the triangle. So this is plus Q, this is plus Q, and this is plus Q. Let's say this distance is x, then this distance is also x, and this distance will be x because this is an equilateral triangle. Electric field due to this charge at point O will be kq upon r square, x square. Electric field due to this charge at point O will be kq upon x square, and electric field due to this charge at point O will be kq upon x square. From a positive charge, electric field is directed away from it, right? So we will apply this concept over here for finding the direction of the net electric field. Now you can see that a total electric field is equal in magnitude for individual charges. So this can be taken as E, E and E. So if you find the direction at point 2, due to this charge, electric field will be away from this one. For positive, electric field will be away from this one, and for this positive, electric field will be away from this one. Okay, now let's find this angle. Okay, so this is 30 degree, right? This is 30 degree. This is 60 degree, right? And we have, this is also 30 degree. Okay, so over here, the angle over here, you can find it as using some trigonometry, right? So this is 30, this is 30. Okay, so let's draw this diagram over here, separate diagram. So this will be E, this is E, and one E is directed downwards. So this is 30 degree, this is 30 degree. Okay, fine. So you can see this thing over here, that this component is E cos 30 degree and this component is E cos 30 degree. Okay, and this component, vertical component, is E sine 30 degree, and vertical component of this one is E sine 30 degree. Okay, fine. Now you can see that E cos 30 degree is cancelling this E cos 30 degree. So overall we have 2E sine 30 degree in upward direction and E in downward direction. Sine 30 degree is 1 by 2. So this will be 2E into 1 by 2, which is equals to E, and this is also E in downward direction. So upward E will cancel downward E. So total electric field intensity at O will be 0. So correct answer is option 3. Next is question number 7. A charged oil drop is suspended in a uniform field of 3 into 10 power 4 volt per meter so that it neither falls nor rises. The charge on the drop will be, so basically its mg should be balanced by QE, right? Force due to electric field on this charge, QE should be balanced by mg. So if QE is equals to mg, then Q will be mg upon E, and m is given as 9.9 into 10 power minus 15, g is 10, divided by E is 3 into 10 power 4. So after solving this one, you'll get charge as 3.3 into 10 power minus 18 coulomb, which is option 1. Question number 8. 2-point charges QA and QB are this and are located 20 centimeter apart in vacuum. What is the electric field intensity at the midpoint of O of the line AB joining the two charges? So we have QA as plus 3 microcoulomb, QB as minus 3 microcoulomb, and separation is 20 centimeter. Okay. Midpoint is O. So this is midpoint. So this will be 10 centimeter, which is 0.1 meter, and this is also 0.1 meter. Now, because of positive charge, electric field is directed away from it. So it will be like this. Let's say this E1 due to this one, and due to this one, electric field is E2. Because of negative charge, electric field is directed towards the negative charge. So E2 is also in the direction of E1. So net electric field at point A will be E1 plus E2. E1 is what? KQ1 upon R square. So K is 9 into 10 power 9. Q1 will be 3 into 10 power 6 minus 6 divided by R square, which is 0.1 whole square. Similarly, E2 is the electric field due to minus 3 microcoulomb. So it will be 9 into 10 power 9 into 3 into 10 power minus 6 divided by 0.1 whole square. So after solving this one, you will get electric field as 5.4 into 10 power 6 Newton per coulomb, which is option 2. Question number 9. The wrong statement about electric field lines of forces. First is they originate from positive charge and end on negative charge. This is true. They do not intersect each other at a point. Yes, otherwise we'll get two different directions for a single point, which is true. They have the same form for a point charge and a sphere. Yeah, you can, if you compare the formula, you'll get the idea about point 3 also. they have physical existence. No, they are this electric field lines are nothing but hypothetical concept, right? So this is hypothetical concept. So fourth statement is wrong. So correct answer is option 4. Question number 10. The surface charge densities of two spherical conductors of different radii are equal. Then the electric field intensity near their surfaces are also equal. Yes, electric field intensity is given as sigma upon epsilon naught. If sigma is same, surface charge density is same, then the electric field will be same. Surface charge density is equal to charge per unit area. Yes, that is also true. Q upon A is equals to sigma. So both statement 1 and 2 are correct. So correct answer will be option 1. Question number 11. An electron having charge E and mass m is moving in a uniform electric field E. Its acceleration will be. So let's say this is the direction of electric field like this, and charge E of mass m electron is moving, right? So force on this will be in the opposite direction of electric field, which is EE, and divided by mass will give you what? Acceleration. So correct answer is option 3. Question number 12. A mass m carrying a charge q is suspended from a string and placed in a uniform horizontal electric field of intensity E. So this is the original orientation. Let's say mass m and it is carrying a charge, initially it is uncharged. Okay. When you place this combination in some external electric field after giving some charge q, then what will happen? Because of the QE force, it will align itself at some angle theta with the vertical, right? To find the new equilibrium location. So this is vertical line. Let's say this is theta. So it will experience mg force, QE force and tension. So this angle is also theta. If you take the components of the tension, so this will be T cos theta and this will be T sin theta. So T cos theta is balanced by mg and T sin theta is balanced by QE, right? So this is T cos theta mg. If you divide this equation with this equation, T cancels. So we have sin theta upon cos theta, that is tan theta, and that is QE upon mg. So theta is tan inverse QE upon mg. So angle of the string with the vertical in equilibrium position is option 4. That is tan inverse QE or EQ upon mg. Question number 13. A cube of side B has a charge Q at 7 of its vertices. The electric field due to this charge distribution at the center of this cube will be. So basically we have out of 8 corners, we have charge at 7 corners. If we have total corners occupied, then net electric field intensity will be 0 at the center of the cube. But we have one corner empty. That means there will be some net electric field. So basically the total net effect created by the 7 corners 1, 2, 3, 4, 5, 6 and 7 is, let's say, E. Now when you place one more charge over here, this total electric field will become 0, right? Okay, that means the net effect due to the 7 charges is balanced by this only electric field of the single charge at this point E, right? So what you can do is, instead of finding 7 different electric fields and doing the vector summation, you can find just electric field due to one single charge that is absent over here, that is on the 8th corner, right? So let's make upper surface like this. Okay, let's say this is the corner where the charge is missing. If there is any charge Q, right, it will create one electric field and it will be balanced by this net electric field, right? And this is the point O, midpoint center of the cube. So this is B by 2 distance and this is this is face diagonal, right? So face diagonal is B root 2. So this is half of the face diagonal, that is B by root 2. So this is another right angle triangle. So using Pythagoras theorem, you can find the value of x. X will be under root of b by root 2 whole square plus b by 2 whole square, right? So this will be under root of b square divided by 2 plus b square divided by 4, which is equal to under root of 3b square by 4. That is x. Okay. Now electric field due to this 8th imaginary charge over here is k q divided by x square, which is 3b square divided by 4. So it is 4kq divided by 3b square. So this should be the total electric field due to the presence of 7 charges at the center of the cube, and that is option 1. Next is question number 14. A uniform electric field is applied into an insulator. The electric field inside the insulator is. So, electric field inside the insulator of dielectric constant K will be E by K, which is option 4. Question number 15. Sound velocity is maximum in. So, velocity of sound is given as gamma RT upon M. So, you can see that velocity is inversely proportional to mass. Mass is minimum for H2, so sound velocity will be maximum in H2. So correct answer is option 1. Question number 16. In a traveling wave, the phase difference between x1 is equals to 3 meter and x2 is equals to 3.5 meter is where the equation of the wave is given over here. So basically, phase difference delta phi is given as k delta x. If you compare this wave with a sine kx minus omega t plus phi, then k will be pi, right? So pi into delta x is x2 minus x1, which is 3.5 minus 3. So this will be pi into 0.5, which is equals to pi by 2. So phase difference in this case will be option 1, which is pi by 2. Question number 17. If you set up the 7th harmonic on a string fixed at both ends, how many notes and anti-notes are present in it? So 7th harmonic, that means we will have 7 loops. Let's say this is one rigid support and that is another rigid support. Okay. And we are fixing the string between these two rigid supports. So in the 7th harmonic, it will create 7 loops, something like this. This is first, second, third, fourth, fifth, sixth, and let's say this is 7th. Okay. So it will be like this, right? So at the rigid supports, rigid boundary, nodes will be there. Okay. These are nodes, nodes. This is again nodes, nodes, nodes and nodes. Okay. When displacement of the particle is 0, nodes are formed, right? And where it is maximum, we have antinodes over here. Antinodes, antinodes, antinodes. This is another, and this is the last one. So if you can calculate nodes and antinodes, nodes are 1, 2, 3, 4, 5, 6, 7, 8. So we have total 8 nodes and antinodes are 1, 2, 3, 4, 5, 6, 7. So we have 7 antinodes. So correct answer is option 1. Question number 18. An organ pipe P1 is closed at one end and vibrating in its first overtone. So this is closed organ pipe and it is vibrating in its first overtone. That means it is vibrating in third harmonic, because only odd harmonics are present in closed organ pipe, right? So it's a frequency of vibration. F1 will be 3 V upon 4 L1, where L1 is the length of the first organ pipe. Another pipe P2 opened at both ends, vibrating in its third overtone. So third overtone, that means the fourth harmonic, right? So P2 is the open organ pipe and it is vibrating in its third overtone, that is in the fourth harmonic. So F2, frequency of vibration of the second pipe, will be 3 into V upon, not 3, it is in the fourth harmonic, right? So this will be 4V upon 2L. 4V upon 2L2. Okay, where L2 is the length of the second pipe. And this are in resonance. That means their frequencies are equal. So you can write 3V upon 4L1 is equals to 4V upon 2L2. We need to find the ratio of L1 to L2. So V cancel. You can cancel it by 2. So we have L1 3 upon 8 as L1 upon L2. Right. So 3 upon 8 will be the ratio of lengths of P1 to P2, which is option 4. Question number 19. A cylindrical resonance tube open at both ends has a fundamental frequency F in the air. So fundamental frequency of an open organ pipe is V upon 2L. If half of the length is dipped into vertically in water, that means we are making it closed, right? One end is in the contact with the water. The fundamental frequency of the air column will be. So fundamental frequency of the closed organ pipe will be V upon 4L dash. We are also changing the length to L to L by 2, right? So it will be V upon 4 into L by 2, that is equals to V upon 2L only. We are decreasing the length by 1 by 2 by dipping this thing in the water, and we are also making it close. So new frequency of vibration will be V upon 4L dash, where L dash is L by 2. So after putting the value of L dash as L by 2, you will get F dash is equals to V upon 2L, which is nothing but the initial frequency when it was open and length was L. Right. So fundamental frequency of the air column will not change, and it is also F. Right. So correct answer is option 3. Question number 20. In a closed organ pipe, standing waves can be formed? Yes. In a closed organ pipe, closed at one end, only odd harmonics are present. That is also true. You'll find frequencies like V upon 4L, 3V upon 4L, 5V upon 4L, and so on, right? So we have odd harmonics present over here. The harmonics which are present in a pipe open at both ends are odd harmonics only. No, in open organ pipe, all odd and even harmonics are present, right? So, third statement is wrong. Only statement 1 and 2 are correct. So, correct answer will be option 3. Question number 21. In a stationary wave, all the particles on either side of a note vibrate in same phase. No, they vibrate in opposite phase. In the region between two notes vibrate in same phase. Yes, in a region between two notes, all the particles vibrate within the same phase. So this statement is correct. Question number 22. A source of unknown frequency produces 12 beats per second with a source of frequency 240. So either the frequency, unknown frequency is 240 minus 12, that is 228, or it is 252, 240 plus 12. Okay, now it depends on the next information given. And 8 beats with another source of frequency 260 Hertz. The same source of unknown frequency is producing 8 beats with the source of another frequency of 260 Hertz. So if it is producing 8 beats, it can be 260 minus 8, that is 252, or it can be 260 plus 8, that is 268. So you can see that the common value that is possible is 252 only, right? So source of unknown frequency has frequency 252 Hertz, and that is option 4. Question number 23. A whistle giving out 450 Hertz approaches a stationary observer at a speed of 33 meter per second. The frequency heard by the observer in Hertz will be where velocity of sound is 330 meter per second. Okay. So basically we have a stationary observer over here. So velocity of observer is 0. Velocity of sound V is given as 330 meter per second. And velocity of source is given as 33 meter per second. And source is approaching observer, that means velocity, apparent frequency will increase, right? Apparent frequency will be more than the actual frequency of the sound. So apparent frequency F is equals to V upon V minus Vs into Fo, which is original frequency. So V will be 330 divided by V minus Vo, that is 330 minus 33, that is 297 into F, which is 450. So after solving this one, the apparent frequency heard by the observer will be 500 Hertz. So correct answer is option 4. Question number 24. The apparent frequency of a note when a listener moves towards a stationary source with a velocity of 40 meter per second is 200 hertz. So we have a source stationary and listener is moving towards, observer is moving towards the source with a velocity of 40 meter per second, and in this case apparent frequency is 200 hertz, which is given as velocity of sound plus velocity of observer divided by velocity of sound into actual frequency FO, right? When he moves away from the same source with the same speed, the apparent frequency of the same note is 160 Hz. The velocity of sound in air is. So, new frequency apparent will be 160, which is V minus VO upon V into FO. Right. So, you can divide these two equations. FO cancel, VV cancel, and this will be 5, this will be 4. So, basically we have 5 upon 4 is equals to V plus 40 upon V minus 40. So it will be 5V minus 200 is equals to 4V plus 160. So V will be 360 meter per second. So velocity of sound is 360 meter per second, which is option 1. Question number 35. Doppler effect cannot be observed if source is moving but observer is stationary. No, it can be observed when there is some relative motion between source and observer, right? So, yes, there's some relative motion, so it can be observed over here. Source is at rest but observer is moving, again relative motion. So, yeah, Doppler effect is there. Both source and observer are moving with the same speed in opposite direction. Again, because of the opposite direction, some relative motion is there. So you can observe Doppler effect in this also. Both source and observer are at rest and there's no relative motion in the fourth case. So there will be no Doppler effect, right? So correct answer is option 4. Question number 26. Length of a string tied to two rigid supports is 40 centimeter. So we have two rigid supports and the length of the string is 40 centimeter. Maximum wavelength in centimeter of a stationary wave produced on it is. So maximum wavelength will be in the first mode of vibration, right? So that is this one. Since these are two rigid supports, nodes and nodes will be created at the two ends, right? The separation between nodes is given as lambda by 2, which is equals to what? Length of the string, that is 40. So lambda will be 80 centimeters. So correct answer is option 2. Question number 27. The equation of a propagating wave y is equals to 25 sine 22 plus 5x is. So over here A is 25 units, omega is 20 and k is 5. Okay. Amplitude of the water wave is 25 units. That is true. Wave is propagating in positive x direction. No, this positive sign over here shows that it is going in the negative x direction, right? So this statement is not true. The velocity of the wave is 4 units. So velocity of the wave is omega by k, which is 20 by 5, which is equals to 4 units. So this is also true. The maximum velocity of the particle is 500 units, right? So maximum velocity is given as a omega, which is 25 into 20, which is 500. So yeah, this is also true. So incorrect option is option 2, which is correct answer, right? Next is question number 28. A tuning fork of frequency 340 Hz produces 5 beats per second with sonometer wire. Okay. So, either the frequency of the sonometer wire is 340 minus 5, which is 335 Hz, or it can be 340 plus 5, which is 345 Hz. Okay, now which one it is true? It depends on the next information given. If the tension in the wire is slightly increased, the number of beats become 4. Okay, if you increase the tension, number of beats decreases. Fine. So, beat frequency is either 340 minus frequency of sonometer wire or it is frequency minus 340, right? Now, when you increasing the tension, lambda into frequency, which is velocity of the wave on this wire, which is under root t upon mu. So, frequency is directly proportional to tension. If you are increasing the tension, frequency increases. If frequency is increasing, then F minus 340 will not give you less number of beats per second. Only 30 minus F will give you more number of beats per second, right? So actually this should be the relation in this particular case for finding the beats, and that is equals to 5. So F will be 335 hertz. If F increases, then and 340 minus F will decrease. If F increases, then F minus 340 will increase. But over here, number of beats per second are decreasing. So first is true. So correct answer is option 1. Question number 29. A vessel of linear coefficient of expansion alpha as A is half filled with the liquid. Okay. On increasing the temperature, the volume of empty space remains the same at all temperature, then the coefficient of real expansion of liquid is. So there's no change in the volume of the empty space. That means the expansion of the liquid is equal to expansion of the vessel. So expansion of the vessel, let's say delta V is vessel ka volume into coefficient of expansion of the vessel. So we have linear expansion A, so gamma will be 3A into change in temperature delta T. Expansion of the liquid is again delta V because both are same, so it is V by 2, only half is filled. So liquid ka volume will be V by 2. That is gamma, which is coefficient of real expansion of the liquid into delta T. Now these two expressions are equal. That means V into 3A into delta T is equals to V by 2 into gamma delta T. Right. So V cancel, delta T cancel. So we have gamma as 6A. So correct answer will be option 3. Question number 30. A vessel is half filled with a liquid at 0 degrees Celsius. When the vessel is heated to 100 degrees Celsius, the liquid occupies 3/4 volume of the vessel. Coefficient of apparent expansion of the liquid is. So initially, like if you don't consider the expansion of the vessel in between, initially you will find that the volume of the vessel is volume of the liquid is V by 2, where V is the volume of the vessel, and finally it becomes 3V by 4. So according to you, if you don't consider the expansion of the vessel, net apparent expansion of the liquid will be 3V by 4 minus V by 2, which is equals to delta V, and that is equals to V by 4. Okay, so delta V is V naught alpha delta T, V naught gamma delta T, right? So initial volume is V by 2 into gamma is, we need to find delta T is 100. So after solving this one, V cancel. So we have gamma as 2 upon 4 into 100, which is equals to 0.005 degrees Celsius inverse. So value of coefficient of apparent expansion of the liquid is option 3. Question number 31. Coefficient of real expansion of mercury is 0.18 into 10 power minus 3 per degree Celsius. If the density of the mercury at 0 degrees Celsius is 13.6 gram per cc, its density at 573 Kelvin will be. So rho is equal to rho naught into 1 minus gamma delta T. So we have initial temperature as 0 degrees Celsius, that means 273 Kelvin. Final temperature is 573. So change in temperature delta T will be 573 minus 273, which is equals to 003, 300 Kelvin, right? So rho naught, which is 13.6 gram per cc, minus gamma, which is 300. Not 300, delta T is 300 into gamma is 0.18 into 10 power minus 3. So after solving this one, you'll get the density value as 12.90 gram per cc, which is option 1. Question number 32. When water is heated from 0 degrees Celsius to 10 degrees Celsius, its volume. So water is not like some other liquid. It behaves differently than other liquid. From 0 degrees Celsius to 4 degrees Celsius, what happens? Its volume decreases. Unlike other liquid, on increasing the temperature from 0 to 4, its volume decreases, right? And after 4 degrees Celsius, it expands. Okay, so first up to 0 to 4 its volume decreases, and from 4 to 10 its volume will increase. So correct answer will be option 4. Question number 33. A glass flask is filled up to a mark with 50 cc of mercury at 18 degrees Celsius. If the flask and the contents are heated to 38 degrees Celsius, okay, so we are creating a temperature difference of 38 minus 18, that is 20 degrees Celsius, not Kelvin, degrees Celsius. Okay. How much mercury will be above the mark? Alpha for the glass is 9 into 10 power minus 6 per degree Celsius, and coefficient of real expansion of the mercury is 180 into 10 power minus 6 per degree Celsius. Okay, so we need to find how much mercury will be above the mark. Okay, so let's say area of the cross section of the glass flask is A. Okay, and no, area of cross section is not required. Direct volume is given, 50 cc is the initial. All right, so gamma real is equals to gamma apparent plus 3 times alpha of the glass. Okay, so you can find coefficient of real expansion is this one, then gamma apparent will be gamma real minus 3 alpha g. Okay, so gamma real is 180 into 10 power minus 6 minus 3 times alpha of the glass is 9 into 10 power minus 6. So this will be 180 minus 27 into 10 power minus 6 degrees Celsius inverse. So we have apparent coefficient of expansion of the volume of the mercury, right? So now we can find delta V is equals to V naught gamma A delta T. So V naught is 50 cc, gamma A is 180 minus 27 into 10 power minus 6 into delta T is 20. So after solving this one, we will get the value as 153 into 1000 into 10 power minus 6, right? So this will be 0.153 cc. So correct answer is option 3. Question number 24. A cylindrical container of volume V is completely filled with a liquid having coefficient of volume expansion gamma. If the level of liquid does not change on heating, then the coefficient of linear expansion of the material of the container is. If level of the liquid is not changing, that means expansion of the liquid is equal to expansion of the container, right? So expansion of the liquid will be V gamma delta T, and expansion of the container both have the same volume, so it is V into 3 alpha into delta T. So V delta T will cancel each other. So we have gamma is equals to 3 alpha. So alpha is gamma upon 3, which is option 3. Question number 35. A U-tube contains mercury with one limb at 0 degrees Celsius and other at 100 degrees Celsius. So we have temperature difference delta T as 100 degrees Celsius. The height of the mercury column are 60 centimeter at 0 degrees Celsius and 62 centimeter at 100 degrees Celsius. The coefficient of volume expansion of mercury per degree Celsius is okay. So basically, because of the increase in temperature, the length of the mercury column in 1 is 62 and it is more than 2 centimeter from the other limb, right? So expansion in the volume is area into expansion in the length. Expansion in the length is 2 centimeter. So area of cross section can be considered as A. So delta V is what? Delta V will be A into delta L. So A is, let's say just A. Delta L is 2 centimeter and it is initial volume V naught into gamma delta T, right? But initial volume is the initial length of the column into area of cross section. So initial length is 60. So it will be A into 2 centimeter is equals to area of cross section into 60 centimeter into gamma into delta T, which is equals to 100, right? So centimeter cancel, area cancel. So we have gamma as 2 upon 6000, which is equals to 1 upon 3000, and that is nothing but 3.33 into 10 power minus 4 degrees Celsius inverse, which is option 4. Okay. Next is question number 36. Two charges plus 4e and plus e are at a distance x apart. At what distance a charge q must be placed from a charge plus c so that it is in equilibrium? Equilibrium matlab net force on it should be 0. So let's say it is placed somewhere over here and separation is d. So remaining separation will be x minus d. So q will experience two forces. One is because of the 4e that is away like this. Let's say it is positive. I'm just assuming that it is positive. So this is F1 and this will be F2. And F1 should balance F2. Right. That means F1 is equals to F2. F1 is force due to plus 4E. So it is KQ into 4E divided by x minus d whole square, and that is equals to F2, which is force due to plus E. So it is K E q divided by x square, not x square, d square, right? So this is k q e cancel. So we have 4 upon x minus d whole square is equals to 1 upon d square. If you cross multiply this thing, you'll get to 4d square is equals to x minus d whole square, and that is 2d is equals to x minus d. So 3d is x. So d will be x by 3. So separation must be x by 3 between q and plus e so that q will be in equilibrium. Question number 37. Electric charges 1 coulomb minus 1 microcoulomb and 2 coulomb are placed in air at the corners ABC respectively of an equilateral triangle having length of each side as 10 centimeter. So let's say this is plus 1 microcoulomb, this is minus 1 microcoulomb, and this is plus 2 microcoulomb. Side is given as 0.1 meter. Okay. The resultant force on charge at C is. So this will experience, this is charge at C, this will experience two forces. One is because of the plus 1 microcoulomb, force of repulsion F1, and other one is because of minus 1 microcoulomb, force of attraction F2. This angle is 60 degree, so this angle will be 120 degree. So angle between F1 and F2 is 120 degree. Cos 120 degree is minus 1 by 2. Fine. Okay, now let's find F1. So it is K 9 into 10 power 9 Q1 1 into 10 power minus 6 into Q2 as 2 into 10 power minus 6 divided by r square, which is 0.1 into 0.1. So this will be 18 into 10 power minus 12 plus 9. So it is 10 power minus 1 only, 1.8 Newton. Similarly, let's find F2, that is force due to minus 1 coulomb. Magnitude of F2 will be again same, 9 into 10 power 9, 1 into 10 power minus 6 into 2 into 10 power minus 6 divided by 0.1 into 0.1. So it will be 1.8 Newton. Right. So we have two forces, 1.8 Newton each of magnitude at an angle of 120 degrees. So resultant force will be under root of F1 square plus F2 square plus 2 F1 F2 cos theta, where cos theta is cos 120 degree, which is minus 1 by 2. So this will give you resultant as 1.8 Newton, which is option 2. Question number 38. If there exists Coulomb attraction between two bodies, both of them may not be charged. One can be charged, other can be, because of the attraction of the positive charges, let's say, towards a negatively charged body, there will be some polarization, and because of that, there will be some attraction, right? So it is not necessary that both bodies should be charged if there's some Coulomb attraction. Okay. In case of Coulomb attraction, the 2-point charges are opposite. That is true. But this statement is not a correct explanation of statement 1. So correct answer will be option 2. Question number 39. The insulation property of air breaks at 3 into 10 power 6 Newton per Coulomb. The maximum charge that can be given to a sphere of diameter 5 meter is approximately. So let's say maximum charge can be given at the at this value only. So it is K 9 into 10 power 9 Q upon R square. So R will be 5 by 2 because this is diameter, which is 2.5 whole square. So after solving this one, you'll get the value of charge as 3 into 10 power 6 into 2.5 whole square divided by 9 into 10 power 9. Right. So Q will be approximately 2 into 10 power minus 3 coulomb. Question number 40. 2-point charges plus Q and minus 3Q are placed at some distance apart. If the electric field at the location of Q is E, then at the locality of minus 3Q it is. So we have plus Q and minus 3Q. Okay. Let's make diagram one more time. We have plus Q and minus 3Q. Let's say separation is X. Electric field at the location of Q is E. That means it is nothing but the electric field due to minus 3Q, which is equals to K 3Q upon X square. So you can see that the direction is towards the negative charge and that is towards right. Okay, so this is 3 times KQ upon X square and you can write KQ upon X square as E upon 3. Now, in the second situation, we need to find electric field at the location of minus 3Q. So, at minus 3Q, electric field will be due to plus Q. And that is towards, not towards plus Q. Plus Q is positive, right? So, it will be away from the charge, that is towards right only. And that is equals to K Q upon X square. But KQ upon X square is E by 3 and direction is also not changing. So no need to add negative sign over here. So correct answer is option 2. Question number 41. The electric field at 30, 30 centimeter due to a charge of minus 8 nanocoulomb at the origin in Newton per coulomb is. Okay. So R vector will be 30 I cap plus 30 j cap in centimeter. So it will be 0.3 I cap plus 0.3 j cap in meter. Okay. So electric field will be, E vector will be KQ upon R cube into R vector. Okay. So this will be 9 into 10 power 9. Q is minus 8 into 10 power minus 9. R vector will be 0.3 I cap plus 0.3 j cap and magnitude of R will be under root of 0.3 plus 0.3 square, right, to the power 3. So after solving this one, you'll get the value of electric field at 30, 30 centimeter as minus 200 root 2 into I cap plus j cap, which is option 3. Question number 42. An organ pipe open from both ends produces 5 beats per second when vibrated with a source of frequency 200 Hz. So 200 Hz is the source of frequency and you are vibrating it with the unknown frequency and beats produced are 5 beats. So either the frequency unknown is 195 Hz or it is 205 Hz. The second harmonic of the same pipe produces 10 beats per second with a source of frequency 420 Hz. So second harmonic of the pipe, this is open organ pipe. So second harmonic will be nothing but the 2 times the frequency of the fundamental frequency. So second harmonic frequency can be either 195 into 2. So this will be 390 and this will be 410 Hz. Okay, this is second harmonic frequencies, possible frequencies. Now, when these are vibrated with the, this pipe is vibrated in the second harmonic with the, 420 Hz frequency, then the beats produced are 10 beats per second. So, either it will be 420 minus 10, that is 410 Hz, and it will be 420 plus 10, that is 430 Hz, right? So, out of this two, common is this value only, right? That means its a fundamental frequency should be 205 Hz, which is option 2. Question number 43. two tuning forks A and B are vibrating and they produce 6 beats per second. Okay. If the prongs of A are loaded with the wax and A, okay, initial are 6 beats per second, A is loaded now, then A and B are vibrating together, the beat frequency is decreasing to 3 Hz. Natural frequency of B is 250 Hz, and after loading, beat frequency is decreasing. That means frequency of A should be more than frequency of B, right? So frequency of A will be 250 plus 6, that is 256 Hertz, which is option 2, right? Next is question number 44. An observer approaches towards a stationary source of sound at constant velocity and recedes away at the same speed. The graph of wavelength observed with the time is. Wavelength will remain constant, so correct answer is option 3. Question number 45. A bus is moving towards a huge wall with a velocity of 5 meters per second. The driver sounds a horn of frequency 200 Hz. Speed of sound in air is 342 meters per second. The beat frequency heard by the passenger is. Next is, a bus is moving towards a huge wall with a velocity of 5 meters per second. The driver sounds a horn of frequency 200 Hz. The speed of the sound in air is 342 meters per second. The beat frequency heard by the passenger is. So you can write F is equals to, just a second. Yeah. F is equals to F naught into V plus Vs upon V minus V. Okay. So over here, this will be 200 into 342 plus 5, that is 347, divided by 342 minus 5, that will be 337, right? So approximately this will be 206 Hertz, and new frequency is apparent is 206. So beat frequency will be 206 minus 200, that is equals to 6 Hertz. So correct answer is option 3. Question number 46. When the tension in a string fixed at both ends is increased by 44%, the frequency increased by 10 Hertz. The frequency of the string is. So initial frequency is directly proportional to under root of tension. So you can write F1 upon F2 is equals to under root of T1 upon T2. Right, new tension is T1 plus 44% of T1, which is 1.44 times T1. So it will be under root of 1.44 T1, not T1, this is T1 divided by T2. So T2 is 1.44 T1. So this will be T1 divided by 1.44 T1, and that is F1 upon F2. So let's say initial frequency is F divided by mu will be F plus 10 because it is increasing by 10. So this is 1. T1 cancel, 1.44 out of square root will be 1.2. Right, so this will be 1.2 F is equals to F plus 10 and 0.2 F is 10. So F will be 50 Hertz, which is option 4. Next is question number 47. Velocity of sound in hydrogen gas at 27 degrees Celsius SV. Then what is the velocity of sound in helium gas at 127 degrees Celsius? So let's make a table for hydrogen and helium, right? So for hydrogen, velocity is V. For helium, let's say it is V dash. For hydrogen, temperature is 27 degrees Celsius, which is 300 Kelvin. For helium, it is 127 degrees Celsius, which is 400 Kelvin. Gamma of hydrogen for diatomic gas is 7 by 5. For this one, it is 5 by 3. Okay. Mass is m, then it is 2m. Okay, so velocity of sound in hydrogen gas is v, which is under root 7 by 5 into r into 300 divided by m. And velocity of sound in helium is gamma RT upon m, which is 5 by 3 into r into 400 divided by 2m. If you divide these two expressions, you can write it as R cancel, 100 cancel, M cancel. So we have V upon V dash is equal to under root of 7 into 3 divided by 5 divided by 5 divided by 3 into 4. Something like this, right? So it will be 7 into 3 divided by 25 into 4, and that is equal to that is equals to 3 root 7, and this is 5 and 4, and yeah, we have this 2 also over here. We have this 2 also into 2, so this will be 2, right? So this will be 2. So we have 7 root 3 V upon V dash as 3 root 7, sorry, and 5 root 2. Okay, so V dash will be 5 root 2 V divided by 3 root 7, which is option 4. Question number 48. The coefficient of apparent expansion of a liquid when determined using two different vessels A and B are 2 delta and delta. This is coefficient of apparent expansion of the liquid. If the coefficient of linear expansion of the vessel A is alpha, then the coefficient of linear expansion of vessel B is. So we need to find alpha B. So let's say gamma R is the coefficient of real expansion of the liquid. So it is gamma A plus 3 alpha. Okay, so you can use this expression for both vessels A and B. Gamma R will be same in both the vessels. So it will be gamma A, which is 2 delta plus 3 alpha, is equals to, for B, it is delta plus 3 alpha B. So this is alpha 3 alpha plus delta is equals to 3 alpha B. So alpha B will be alpha plus delta by 3, which is option 3. Question number 49. If the coefficient of real expansion gamma R is 1% more than the coefficient of apparent expansion, that means gamma R is gamma A plus 1% more than apparent. So this is 101 gamma A upon 100. So gamma A will be 100 gamma R divided by 101. Okay, the linear expansion coefficient of the material is, sorry, this is gamma R. We need to find alpha. So we can use this expression for finding alpha, that is gamma R is equals to gamma A plus 3 alpha of vessel, right? So gamma R is equals to gamma A is 100 gamma R divided by 101 plus 3 alpha. So it will be 101 gamma R minus 100 gamma R divided by 101, and that is equals to 3 alpha. Okay, so alpha will be gamma R divided by 303, which is option 1. Question number 50. If on heating liquid through 80 degrees Celsius, the mass expelled is 1 by 100 of mass still remaining, the coefficient of apparent expansion is. So it is given as mass expelled divided by mass remaining into change in temperature. So it is x upon 100 divided by x into 80. So it is 1 upon 8000, and that is equals to 1.25 into 10 power minus 4 per degree Celsius. So correct answer is option 1. So that is it for today's session, everyone. I hope you had a wonderful experience with this paper. So I'll see you again with the next paper very soon. All the best, everyone. Take care. Bye.